Hi, good morning everyone. Today I'm going to talk about my research topic on DC distribution to the domestic installations. Let me introduce myself. I am Prithvi J. Chandra. My student ID is 5290284. I am pursuing Masters of Engineering at University of Wollongong, Australia. Let me tell what is DC distribution and what is AC distribution. What are the difference between AC and DC? AC distribution system, the voltage and the currents goes from maximum to the zero and zero to the maximum and from positive to the negative. But in case of DC distribution systems, the DC power is always constant. The voltage and the currents remains constant throughout the operations of the source. Let me tell why DC distribution is important in the present days. Today in the present society, most of the loads or DC loads like computer, electronics, devices like mobiles and iPads, and the plantation of the fossil fuels in the Middle East countries has really made the people to more depend on DC distribution sources, and the maintenance of AC type distributions is difficult and really very expensive. Let me tell what are the causes, what are the losses during AC to DC conversion process. The power is lost during AC to DC conversion process in a converter, and the voltage drop across the converter causes or reduces the efficiency of the loads, and the leads to an explosion of the gadgets or electronic items, or the failures of the motherboards in a computer is one of the good examples for the failures of electronic devices. And coming to the tool, I would like to explain what are the tools I used in my research. I used simulation software, MATLAB simulating modeling, alternative programming techniques called ATP, and the practical experiments on different semiconductors family. We operated the converter for different semiconductors like diodes, thyristors, MOSFETs, and capacitor and inductors. What was the outcome of the literature review and what was the gap? I gone through many papers and some research there was a gap. We find out the gap between the last and the present trends. So there was a maximum power point ranking was one of the good improvement for the process improvement. We placed an MPPT techniques we introduced into the PV cells to extract more solar radiations from the sun and feed into the battery through conductors. And the extraction of the DC power solar radiations emits an electrons which causes motion of electrons. And coming to the converter part, AC to DC conversion losses can be reduced by using thyristors control rectifiers by controlling the input gate pulses, and you can obtain an output voltage according to the requirement of your loads, and this we call it as technological improvements. Coming to the research design, let me brief about my research design. I gone through the MATLAB simulations and we conducted some modeling process. We got some results, and the main outcome of the research design was we introduced a boost circuit. What is a boost circuit? Let me tell something brief about the boost circuit. The boost circuit is which works on principle of the input voltage and output voltage. The output voltage is always greater or twice or double than the input voltage. So when we introduced the boost circuit in the research design model, the lost voltages in the converter is recovered or regained. And what were the outcome of results? Simulations results were compared with an experimental results, and they were really matched, and it wasn't successful in leading an efficiency of the devices or the converters. And this is my proposed model of the converter circuits. This is a PV cell inverter. The main working principle of inverter is converts DC from battery to the AC, and the converter is a reverse process. It converts AC to the DC. And the boost converter just boosts the DC outputs, which boosts the main working principle of boost converter is, as I already told in the previous slide, the output is always greater than the input, and the output is fed into the DC loads like computers and some gadgets maybe. And let me explain what are the limitations, what are the disadvantages of DC distributions in domestic installations. Some countries like European countries, the winter season or rainy season snowfall may result in bad weather for the solar cells, covering the snowfalls on the PV cells, which really blocks the solar radiations. And this is one of the disadvantages in the European countries. And coming to the solar radiations are absent during rainy seasons and in the European countries. And the unbalanced DC loads causes a voltage fluctuation in the lines of the conductors, causing the variation of the power factors and the supply voltage more are behind their limits. And what are the ethics? Ethics is nothing but good and evil of the design or research design. There are some really evil things that going to be predicted in our product. Ethics, coming to the ethics, non-renewable energy suppliers may reduce their cost per unit kilowatt or watt to just make a competitor to the renewable energy users or to attract the more consumers. And initially the redesign project companies may reject as they are worried of their quality and their warranty periods. They may suppress us not to install in their customer places. And coming to the reference materials, we used primary sources, articles, journals, conference papers, and secondary sources, textbooks. I even consider them, and IEEE papers, journals, and articles. And I would like to say final thank you to all for watching my video. And I would like to consider that installation of DC distribution system is really going to advantage in terms of financially. Some of the governments, Australian governments, has supported the DC installators by reducing their tariffs, taxes,